Okay. Okay. Thank you for your kind introduction, Alexei. And my talk, it's about laser here. Okay. Natural products database as valuable source of bioactive structures for virtual screening. Well, my name is Marcos Túlio Scotti, and I'm a professor at the Federal University of Paraíba. Paraíba is located in João Pessoa. João Pessoa is the capital of Paraíba state. Brazil is a very huge country, and it's a federation. And here is Paraíba, João Pessoa, and the distance between João Pessoa and São Paulo, the most important city in Brazil, it's almost 2.8 kilometers, 1,000 kilometers. It's about 3 hours by plane. And João Pessoa, it's a nice city with a nice sea coast. And the temperature in the summer is between 31 degrees of maximum and the minimum of 24, 25. And the winter is not much different. The maximum temperature is about 28, 29, and the minimum is 24 Celsius degree. So it's a warmer place all year round. So let's talk about our cheminformatics lab. We conduct studies in computer-assisted drug design, and KISAR, structure-based, and the ligand-based virtual screening. Some studies in environmental cheminformatics, and of course, natural products database. Let's talk about the natural products. Natural products is an important source of biological structures. Here you can see some studies, some papers published by Newman and Craig. And these 5 papers reports the influence of natural products as an important source for the drug approvals since 1981 to 2019. And you can see here that the influence of natural products to drug approvals is increased. In 2002 is about 61%. Now, not now, but in 2019, it's about 75%. And oops, just a moment. Yeah, it's working now. Yeah, okay. Other interesting paper regarding screening of natural products databases. It was published by Harvard and co-works. And in this paper, there are several sections. One section is about natural products databases. And the other interesting point in this paper is about the biological importance of natural products databases. So here you have 2 databases, a small one of natural products and a larger one of zinc database. It's a commercially available chemical space of 22 million compounds, and the smallest is about 106,000 compounds. So you can see here the difference of the drug-like compounds of each database. In the zinc database is about 71%, 72%, and in the natural products database is more than 10%. So it's about 10% more, 81 point. I cannot hear you. Okay, 81.2%. So yeah. So nowadays the increase of the number of the structures and related to biological activity reinforce the development of databases allowing significant support for drug discovery, and it's important to the classification and organization of the information. And the database provides a collection of systematic information of natural products and their derivatives. So computational approaches have played an increasingly prominent role in natural product-based discovery. And for example, the development of the use of natural products database allow access to the numerous chemical, biological, pharmacological, toxicological, and the structural natural products data. Recently, Sorokina and Steinbeck published a review reporting the available natural products database, citing more than 120 examples, and noted that the access to the information was limited in this database, and only a few of these databases were sustainably managed and continually developed. Let's talk about our system, Systematic. We started to develop Systematic in 2008. It was a simple Java application that you need to install in your PC and access a MySQL database in the same computer or using a local area network. Well, but web tools have several advantages for the desktop applications. First, you don't need to install, and you don't need a powerful computer. You can use a server for the calculations. You can use it in the different devices and different operational systems. You only need a browser and internet, but sometimes you don't have it. So it's me without internet. And in 2012, we start to build a web application, a web version of Systematic. Here you can see the screens of the first version. We use the HTML, CSS, Java, and JavaScript language. And we implement several APIs. APIs is application program interface. Most of them from Ken Axon company. We use only one API from Kendodo just to visualize the 3D structures of the compounds, and the Google Maps platform to visualize the locations, geographic location of these species. Well, here I have the UML, the Unified Modeling Language. I won't give more details, but the user can, using the front end of the system, can perform several queries, register data, deleting, and so on, accessing your database. Sorry for some words in Portuguese, the user and your database. And the most important slide is that the user is very happy using our system. And here we have the architecture of our database. In green are the tables responsible for the botanical data. In yellow, the data of the compounds, including the fingerprint. And in red are the table for the experimental data. Well, we have several problems of everybody who works with code, building scripts, softwares, and web tools. So the first problem is when your code doesn't work and you have no idea, but it's not the more important problem, because at the end you have to know how it works and solve this problem. And the biggest problem when you have the code that works and you have no idea why. So you must improve your system. It's like a F1 car. So you must improve your system. If you have to improve your system, you must know how the code works. So in these last years, we're improving the Systematic and implement some security to avoid hacker attacks and fix several bugs. Here you can see a screen of Systematic X Web. We registered the software in 2015, 2016. Here's the address of your system. And in 2016, we compare Systematic X with other natural products database. You can see in this table, in 2016, some queries don't have some queries that are present in other database. In 2 years, we implemented all these queries that are highlighted in red. And then in 2018, we published the first paper of your system as a technical note in Molecules journal. And here I have some screens of Systematic X. It's a very friendly web tool. So the user can draw the structure and perform the search, or input a smile code, can search by name, compound name, common name, UPAC name, and it's possible to search by species name, tribe, family, and so on. So when perform a search, the mechanism generates a results page with 6 results by default, but it's possible to change the number of the compounds for per page. And when a result is selected, the user has access to the data for that compound. So you can see here, we have the information, data about the compound, the structure, secondary metabolite, and botanic data. So species, genus, tribe, family, where which this compound was isolated, and of course the geographic location using the Google Maps API. So here we have a table with some properties that are predicted by the Systematic X using these APIs from Kinaxon, Kindodo, and Google. And an interesting feature of the Systematic X is that it's not only a system, a web tool to consult the data. So it's possible to input the data and modify, deleting the data. So user can log in your system and manage the data directly in the web tool. And it's very simple to visualize if one compound is already in your database. Currently, we have more than 90,500 different secondary metabolites arising more than 20,000 botanical occurrences. Botanical occurrence is the number of the different species that one compound on one secondary metabolite was isolated. So in this table, we have these families and the number of the secondary metabolites and the respective botanical occurrences. It's not a huge database. We're focusing on developing the system, the web system, not the database. Since in 2018, Systematic X has reported more than 5,000 users and more than 90,000 sections. So one user has more than one section. Most of them in Brazil, sure, but it's almost 50% look at the outside Brazil, mainly in Germany and the United States and France. Some papers that our lab published, and using our database, performing virtual screening of our database, and to predict some biological activities of secondary metabolites against Chagas disease, SARS-CoV, and Alzheimer, and so on. Some other papers published for other groups, systematics. In this first paper, using your database for performing virtual screening to finding inhibitors for leishmania major dehydroxyurate dehydrogenase. Other papers published criticizing or a system. So in this paper, the author highlighting the systematics for its use of Google Maps application. In this review, Misra and Mohapatra noted that systematics was an easy tool for metabolomic studies. And the last paper here, and you can see the author criticized the inability to perform book downloads in the systematics environment. So we followed these suggestions and improved the systematics. And then in 2021, we published our update of your system. And what's new in systematics? So you can generate the visualization NMR data. We have a lot of biological activity predictions using PASS. Some other properties predicted by the APIs of Kenaxon. And it's possible to perform a batch download. In this table, we have a list of the some properties that are implemented in 2020. And these new features, it's useful for the scientific community, user, and some partners. Now, so when you select one compound, you can see these new properties predicted by Kenaxon. And then it's possible to perform some filters. In this filter, you can input the range of some properties and select them. As I said before, now you can predict systematic X using Kenaxon APIs, can predict the NMR spectra and visualize the spectra. When users click in one chemical shift or Copeland constant, can visualize in the 3D structure the atoms and the respective NMR data. So, and now have several biological activities predicted by the PASS filter. At the beginning, we have more than 4,600 pharmacological effects and mechanism of action, but we insert a cutoff of 50%. So it's possible to visualize more than 1,500 predicted pharmacological effects and mechanism of action. When selecting a compound, you can visualize the prediction, the probability of prediction of the compounds. And it's possible now to download, batch download, the entire database or the results of a simple search. And downloading the search results a CSV file of the information of the structure, it's my structure, and the botanical occurrence and some properties. Currently, you have a partnership with Embrapa. Embrapa is the, how can I say, I have here the name in English of Embrapa. At the moment, I'm almost finishing my presentation. Okay, here. It's the Brazilian Agricultural Research Corporation. Embrapa is responsible for the development of the technological basis for agriculture and the livestock. And the project is coordinated by the Embrapa side for Guilherme, Dr. Guilherme João Zocolo, and Lorena Marax Alexander. And we have another partnership with the University of São Paulo, is coordinated by Professor Fernando Batista da Costa, of the Laboratory of Pharmacology, Pharmacognosy, of School of Pharmaceutical Sciences of the University of São Paulo. And as I said before, it's possible to perform virtual screening using Systematics Web. So you can combine the data of your database with other databases, for example, Kimbell. And after selecting the compounds, we already have some interesting information as NMR data, geographic location, and botanical data. And this paper we published the last year used a small database in Systematics to select only the chlorines, and they perform a combined approach using ligand-based virtual screening and the structure-based ligand screening, virtual screening. And in this combined approach, use a consensus analysis. And after selecting some compounds, we tested in vitro against the Leishmania major pipteridine reductase, so experimental validation. For this, for the training set, we selected from Kimbell database more than 600 compounds with AC values against the Leishmania major, and divide the compounds in activity and inactivity ones, using a cutoff of PIC 50 of 5. Descriptors are using the Volsoff descriptors. These are 3D descriptors using probes. And in the ligand-based virtual screening, we selected 7 compounds, 7 secondary metabolites. As I said before, it's possible to know the species where these compounds were selected, or isolated, sorry. And after performing the consensus analysis between structure, virtual screening and ligand-based virtual screening, we have 5 compounds with potential activity against the Leishmania major. And we selected 2 of these compounds for in vitro tests. As I said before, our cutoff was PIC 50 of 5. That means that IC50 for the active compounds is greater than 10 micromolar. So for both compounds, the IC50 was less than 10 micromolar. In this case, both are less than 10 micromolar, 8.6 and 90.6. And I have to mention other important platform. It's a natural products online platform. It's open source, open data repository for natural products. And this repository natural products is developed and maintained by the Professor Steinbeck. Professor Steinbeck, I think, yeah, it's professor at the Friedrich Schiller University in Germany. And here we have the staff of our laboratory. It's coordinated by me, of course, and my sister, Luciane Scotti. Currently, Eugene Muratov of the University of North Carolina is a visiting professor. It's the most important that he supports the Palmeiras. Palmeiras is an important soccer team in Brazil. And here you can see our doctoral students, Renata, Priscila, Tione Herrera, Isadora Silva, Natalia Ferreira, and the master students, Nathan. And the undergraduate students that are responsible to develop nowadays the Systematics, Emanuela Faustino, Avila, and Lucas. I would like to thank you for your attention. So you can see here, Area Vermelha, it's a nice point in João Pessoa Coast. And thank you. It's finished.
Thank you, Marcus, for interesting talk. We have a time for questions, and I have several in the chat. First from Anastasia Rudik, how are data entered by third-party users verified?
How is do you mean how it's created, the created database? To verify the structures? Is this the question?
Yes.
Yes. So in the I don't know if I can let me. It's possible to show in the. Let me show in the. I think it's online systematics, but when it's possible to select connect several databases. So PubChem, ChemSpider, and so on, and you can verify if the structure is the same in this database. So let me show you. I think you can see my screen.
Yes.
Yes.
Yeah. So customize. I think it's faster. So we can connect to several databases. So ChemBL, PubChem, ChemSpider, and then connect. Click here, so you can verify if it's the same compound. So first, before you input the compound, you verify, but after you can check again. So you can verify if this the same structure, if the same name, and so
on. The question was when the user input in your database the data, are they verified or?
But verify if the compound is already in the database, of the structure of the compound is correct.
They can input only structures, or they also input the plants from which.
Yeah. You can input the plants, input the class, skeleton. So I can say I can show here the data which we use. So the user input the structure and the name, common name, the class, the skeleton, and the botanical data, and of course the geographic data too.
Yes, and how you check that user put correct data?
Okay. We have different levels of users. So we have a administrator and the simple user. When user input the data, the administrator can verify the new data and check if it's correct or not. So when you put the data, you have the reference of this data. So you can see here the reference, and okay, it's just one minute, but you can check if the data is correct. I don't know if I answered the
Thank
question.
you. Yes.
Okay. Let's answer next question. Vladimir Sulimov asked you, do you have all 3 compounds from your database on the shelf? Are all molecular structure of these compounds available in SDF format? Is it possible?
No. I understand that the question is regarding if you have the samples of this compound.
Some, okay, no, don't have 90,500 samples, but some we have a collaboration of important phytochemistry laboratories. Some of them we have. So in the last paper, we already have these 2 compounds. So after the select and predicted the compounds, the secondary metabolites with biological activity, we check if they are if this lab that we have some collaborations have this compound. So in the Federation University of Paraíba, we have a partnership with an important natural products laboratory that have several compounds. So okay, I think we have more than 100 samples, but not much more of that.